All right, with that, we will move on to Chip's presentation about
Thank you.
Raspberry Pi.
Thank you. And let me start out by saying that this is not the presentation I promised to make, nor is it the presentation I wanted to make, because I'm a long time Raspberry Pi guy. I ordered the Pi 5 the day it was publicly announced, and they told me that it would be delivered before the end of October. It wasn't. So, but I can fake it. I did demonstrations for Hewlett Packard for 15 years. I can fake any demo. So these are the things I'm going to kind of cover. How many people have used Raspberry Pi? If you get bored, it won't hurt my feelings if you go ahead and leave. But I think you'll see some stuff here you probably haven't run into before. I want to talk a little bit about the history, because the Raspberry Pi Foundation really is an admirable group and kind of phenomenally successful and interesting. I'm going to talk about the Pi 5. I don't need one to go through what makes it different from the other Pis. Can you guys hear me at home? Somebody, I can't see, never mind. I hope they can. Steve heard me a while ago, so presumably they can. But I've got the specs for it, and we can talk about what makes it different. We'll talk a little bit about Pi availability, because it's been interesting. And because Pi 5 is not available, and because of the availability issues, I spent some time in the last year. I use a lot of them, more than like radio stuff. I've got many more Raspberry Pi and single board computer things than I want you to tell my wife about. So I'll talk about some of the alternatives a little bit, in particular Orange Pi, which is interesting. That's another discussion. There is a lot of amateur radio stuff available for the Pi series. Talking some about that and why single board computers, SBCs, are particularly interesting to me and why they might be interesting to you. And finally, I've got a slide on what the difference is between SBCs and Arduinos. And if we need to talk about that, I'll be happy to, just to kind of complete it. And I'm going to start with playing this video. I hope the audio comes through.
You might have to break the share, Chip, and then remake it with audio enabled.
Oh, okay. Do what?
You turn off the share and turn it back on with audio enabled.
Oh, okay. The reason I want to play this video is I thought about doing a slide on Raspberry Pi history, and Eben, the founder of Raspberry Pi, does a much better job of it than I can, and in a much shorter period of time. And it's kind of interesting to listen to him. So that's it, and it's like 4 minutes. So
That should work.
okay. Yeah. Let me go back to a slideshow. Okay. I lost my mouse, my cursor now. Uh-oh. Come on. Yeah, but it goes away. There we go. Yeah.
Name, so he could type Martin, and it would say, hello, Martin. I would type my name. And
again,
it would say, hello, Evan.
Hopefully,
that was just infuriating to me. A Raspberry Pi is something that I guess has its genesis really in my childhood. So I was born in 1978. I had a friend whose name was Martin, and he had a computer in his bedroom. And that computer was called the Acorn Electron. Now, the Acorn Electron was another, like Raspberry Pi, a computer designed in Cambridge in the UK. And he could just write very simple little computer programs. So he could write that program that gets you to input your name, so he could type Martin, and it would say, hello, Martin, or I could type my name, Eben, and it would say, hello, Eben. And that was just infuriating to me that my friend could do this thing. It just seemed like such an attractive thing to be able to do. I got a BBC Micro eventually of my own. I bought a second-hand BBC Micro and I had it in my bedroom at home. And I learned to program on it. I would program in the lunch times and the break times at school. I'd program in the evenings at home. So when I went to university, it was the most natural thing in the world for me to decide that I wanted to go to university and study computer programming. So when I arrived in Cambridge, what I found was that the people I was with, my fellow students, almost all of them had had that route into computer programming. It hadn't been a matter of learning about computing at school. We all had this hobbyist route into computing. I think what we discovered subsequently is we didn't know how lucky we were. We didn't know, we didn't really know where our students were coming from. We just knew we had a lot of them and that they knew what they were doing. And then things changed. By 2004, I was involved in interviewing undergraduates. I'd gone from being an undergraduate to being what we call a Director of Studies. And the job of the Director of Studies is to organise the undergraduate teaching for a subject and also to go and organise that there should be more undergraduates. And I still remember going to the office, going to the tutorial office at St John's College in Cambridge in the autumn of 2004. And I went to collect my folders. I went to collect, each student has a folder, and I went to collect my pile of folders, and I was expecting a pile of folders like this. And what I got was a pile of folders like this. 8 or 9 folders, where perhaps I might have expected 30 or 40. And what we came to, over a period of a couple of years, really, there was no moment of blinding insight, but over the course of a couple of years, what we came to realise was that those machines that had been my way into computing, those machines that had been my fellow students' way into computing, they disappeared. You know, the BBC Micros, the Commodore 64s, the Sinclair Spectrums. What had happened? Though general purpose computers as the platform for computer games had been replaced by games consoles, and this was the first part of what I think has been an ongoing trend. We all carry around in our pockets today machines which are vastly more powerful, our mobile phones, machines which are vastly more powerful than the machines of the 1980s. No one ever bought a games console, no one ever bought a mobile phone and had that be their ladder into engineering and computer programming in the same way that the BBC Micro was for me and for my friends. I've always described it as a hypothesis test, and I think it is still a hypothesis test. And the hypothesis is, if the computers went away and then our students went away, if the computers come back, maybe our students will come back. And we very quickly decided that our intervention to try to solve this problem would be that we would create a computer. Very, very early on, we settled on 4 things that we wanted this computer to do. We wanted it to be fun, actually. And what does fun mean? Fun means it can play games. Fun means that you can play videos on it. Fun means you can surf the web on it. But that fun should come with a frictionless opportunity to go from pure fun, pure consumption, to creation, to doing something creative yourself. So that was important to us. But what we wanted was a device that could survive the rough and tumble of being owned by a child. Finally, we wanted it to be cost effective, we wanted it to be cheap. If you're going to ask people to go out and buy a whole special thing in order to participate in computing, it wouldn't make sense if that thing cost hundreds of pounds. We built a bunch of different prototypes. So we started off in 2006 with a device which was actually barely more powerful than the machines from the 1980s. And it was very, what was attractive about that machine? It was about this size, and you could build it with a soldering iron. It was built on a piece of Veroboard. By 2008, we had a platform which ran Python. That machine also felt deficient, and the way that that machine felt deficient was that we had to do everything. If you write your own SD card drivers, your own file system, your own graphics drivers, your own text editor. And so that wasn't going to work for us. But by 2010, we had something that felt much more like Raspberry Pi. What was the big change? We decided we were going to build our platform around Linux. So by the start of 2012, we had something we thought we could make for the price. On the 29th of February, we made Raspberry Pi available for sale, and we sold 100,000 Raspberry Pis on the first day. Crashed both our partners' websites, sold 100,000 on the first day. Now, that was 10 years ago. How time flies. What does this mean in terms of our metric? People applying to the university at Cambridge. Well, we've gone from a little over 200 people applying for a little under 100 places, so roughly a ratio of 2 to 1, to over 1,400 people last year applying to study computer science at Cambridge. It's gone from being one of the least competitive subjects to one of the most competitive subjects. So that's a wonderful thing, that single metric. There's something like a factor of 40 performance difference between the Raspberry Pi 4 that we're shipping now and that Raspberry Pi 1 that we shipped back in 2012. And the wonderful thing is that we've been able to deliver that performance increase while holding to the same $35 price point as Raspberry Pi 1. Raspberry Pi was founded with a mission to put affordable computing in the hands of people all over the world. We've made a lot of progress on that in our first 10 years, and really the dream is by the time we get to our 20th anniversary that there will be nobody in the world who hasn't had the opportunity to have a low-cost, high-performance, general-purpose computing experience. There we are, Raspberry Pi. Thank you very much.
Yeah, I thought that was a wonderful video. I hope you guys enjoyed it, because I remember being an electronics hobbyist in the 60s, 70s, and going to Radio Shack and buying bags of resistors and transistors and stuff and building. And that's all gone away. And same thing with computers. The first small computers I worked on, I built 4 or 5 of the first M-size delivered back in 74, 5 to control the first particle accelerator decelerator in the United States at the physics department at Missouri School of Mines. And that was a hobbyist computer. And by the time we got to 2005 to 2010, there wasn't really any such thing. And these guys they've succeeded in bringing that back. One of the reasons I like Raspberry Pi is because of that philosophy. They're still a nonprofit organization in the UK, which is interesting. And I should have mentioned up front, this talk is not going to be as radio focused as I would have liked for it to be, but I am going to talk about ham radio stuff. Okay. Raspberry Pis, many of them are made in a Sony factory, but it's in the UK, and it's a neat factory. I've seen tours of it, and they're very enthusiastic about building Pis, building computers for everybody, which is neat. There are many single board computers available right now, and other hobbyist computers again. My God, they're reintroducing the Atari 2600. Yeah. And the Commodore 64, for God's sake. Anyway, but of all the hobbyist computers out there, all the single board computers, all the other electronic stuff, there is no, kind of like our ham radio club here, there is no community like the Raspberry Pi community. And support from the manufacturer. I'm going to talk about some other single board computers. The Raspberry Pi operating system is absolutely unique anywhere. Compared to Microsoft, even Ubuntu, which I'm a fan of. It works. It just works. And throughout the entire evolution of the Raspberry Pi family, same operating system works across the entire family. That's unheard of and magical. The operating system is stable, it's standard, it's just wonderful. There are, last count, something like 4 dozen other operating systems available you can run on a Raspberry Pi. I have, in fact, run Windows 10 on a Raspberry Pi 4. It struggles, but it does it. And the guys I have talked to running it on a Raspberry Pi 5 say that its performance is entirely acceptable. It's not, I mean, it's a $50 to $80 computer. It's not a Intel 7, but it's a perfectly acceptable desktop system. And finally, there is nothing else around that has the amount of stuff that you can buy to stick onto a Raspberry Pi or put around a Raspberry Pi or load into a Raspberry Pi to run. It's just an amazing environment. This is the Raspberry Pi family. I'm not going to go through any detail on this. I just wanted to kind of point out how rich it is. And I'm going to start, I've got a bunch of stuff that rather than doing a lot of demos, I'm going to pass crap around for people to take a look at. This is a Raspberry Pi 4 in a little tiny form factor running on a battery, and it's just cute as hell. So that's the only point I wanted to make here is the depth of this family and how much it's grown over the last few years. It's just amazing. How many people have used or have a Pi 400? Okay, cool. I got something I can show you haven't seen before. Like the Commodore 64. This is a Pi 4 in the standard Pi Raspberry keyboard with 2 display outputs and the GPIO and everything else. It is a complete computer and a keyboard. The only thing you really need to do is stick a power supply, a monitor, and a mouse. I don't know why they didn't put a touchpad on the damn thing, but it cost. Everything about Raspberry Foundation is cost, and that's why the Pi 5 is kind of limited in a way. Again, I'm not going to talk about the details of this. It'll be in the notes, and if anybody wants to look at it. But the point is just the depth and breadth of this family, and it doesn't even include all of the stuff they've done. Okay, so let's talk about the Pi 5 for a minute. Still a quad-core 64-bit ARM processor. From the reviews, I've heard the video is astonishingly good for a $50 computer. There's still 2 high-resolution outputs. The big things that people are going to notice is speed. The Wi-Fi, Bluetooth, and hard drive connections and the USB speeds are dramatically increased. It's still 2 USB 3 ports, 2 USB 2 ports. The big thing is, finally, we have PCIe on Raspberry Pi. This is cool. But again, cost dictated what they could do with it, so it's a single lane PCIe. It's okay. So it doesn't support full speed NVMe, but it's a hell of a lot better than an SD card. The people that I've seen doing reviews of pre-release versions of it say that it is unlike the Pi 4, which you could use for a desktop computer, and I have, and it's just adequate. The Pi 5 is a fully satisfactory desktop computer environment as long as you're not doing really sophisticated video editing or things like that. Finally got a real-time clock built in, which is cool as hell. A power button, thank God. Anyway, so that's as much as I know about the Pi 5 right now, unfortunately. This is a picture of it. It looks astonishingly like the Pi 4B. The one thing that people that have gotten used to the 4B are going to notice is that the I/O chip down here is the Raspberry Pi Foundation has moved up in the world. They are designing chips now, and it looks very much like they are going to be designing the next system on chip for the next generation Pi. The 5 is kind of a stopgap. They're headed up in the world. But that custom chip on there is the first fully Raspberry Pi Foundation developed integrated circuit, and it's a very sophisticated I/O controller. Controls all the USB, PCIe, too many acronyms, and a camera, I/O, and everything else. And that's a pretty significant development capability. So the fact they've been able to do that with the support of the TSMC people, and they are tightly coupled with Taiwan Semiconductor, makes me very hopeful for the future of the Raspberry Pi group. Incidentally, when he talked about 100,000 orders on the first day, they also, by the 6-month mark, had orders for 40,000 in-house, which is mind-boggling. And to date, they have shipped something like 50 million Raspberry Pi products. That is revolutionary. I know there are significant numbers of villages in Africa, for example, where they had an old television that they'd turn on the generator or have somebody cranking a bicycle generator so that the village could watch TV for the evening. And that's why they put this yellow connector for plain old video out on the first generation so that you could ship a $30 computer and a $5 keyboard and mouse to some place where they could find a 5-volt power supply and have somebody run the bicycle to power the television, and they could have a computer. So again, admirable. Okay, availability and alternatives. If anybody tried to order a Raspberry Pi 4 last year, you know. Are we okay? That, no, that's my getting a call. What the hell? And who is that? That's confusing. Sorry about that. My phone is coupled to the computer, and I didn't really know it was until I got things like that happening. So it's kind of frightening how things talk to each other anymore, you know. Anyway, if anybody else tried to order a Pi 4 last year, it was a frustrating experience, and they are catching up, but because of that shortage, people started looking for alternatives. And since Raspberry Pi Foundation pioneered this market segment 10 years ago, and last February was the birthday of the Raspberry Pi, 10-year birthday, by the way, SBCs have exploded. There's dozens of different SBCs around. If anybody wants to look for alternatives, there's a guy on YouTube, content creator, that I highly recommend, called explainingcomputers.com. It's a great website, but he does detailed analysis of competing single board computers and operating systems, and in-depth explanations of what's different between NVMe, non-volatile memory, whatever it is, and eMMC, which is what's on a couple of the machines. That's embedded multimedia card, and all the other technologies. He's a neat guy, neat British accent too. Finally, in my opinion, none of the other SBCs come close to the Pi for price per performance, which is a key issue. Ease of getting started. I've got some orange Pis up here. Hardware is fantastic. When I should have been working on this presentation for the last month, I've been trying to get the operating systems on the damn things working. Anyway, and as far as I can tell, they're in the top tier of ease of use, the Orange Pi is, compared to a lot of the other single board computers out there. Raspberry Pis, you get them out of the box, you follow the 3-step instructions, you plug the SD card in, and they work. The operating system's wonderful. And again, I want to mention the support. The community is astonishing. Anything you can imagine wanting to do with a Raspberry Pi, somebody's got a video about it on YouTube. They may have weird accents and may be hard to follow them, but it's on there. Nothing comes close to the amount of add-on hardware there is for Raspberry Pi. HATS, which is hardware above whatever, but it's stuff that sticks onto the GPIO. Software and manufacturer support's amazing. If you have an issue with the Raspberry Pi and you send them an email, you'll probably get a response. Try that with one of the Chinese manufacturers. Okay, now talk about the orange Pi. I've got two of them here. For every model in the Raspberry Pi line, the orange Pi people, who are very Chinesey, forgive the. I talk a lot, having done technical writing for years. Dave will remember me in that role. I talk about Chinglish. And if you've read manuals that have been machine translated, they're hilarious but terrifying. Anyway, for every model you can find in the Raspberry Pi line, like the 400 keyboard I'm passing around, this is from Orange Pi. Look, that's as close to an exact copy as you can get, except it has a little orange on the button where the Raspberry Pi one has a raspberry. And it has a VGA connector for some reason. But other than that, it looks and acts like a Raspberry Pi, except of course the operating systems won't work on it. When I say support for Orange Pis are minimal, that's being generous. If you need help, there are some YouTube videos, but they're marginal, and the communities, there isn't one. The most frustrating thing I found, if you've dealt with Chinese.com in the sky, it does some great hardware. Software, not so much, if you've dealt with any of their software products. And coming from the Raspberry Pi environment, where you download the Raspberry Pi image, and it doesn't matter which one you've got, you burn it to an SD card and plug it in and it works. With the Orange Pi, it's not like that. You have to download a different image for each product, and they never get updated. If you pull a terminal and run an update, there isn't any. So whatever they did the whoever did the code modification to get it to run, it's pretty much what you got. The Orange Pi OS that they have on their website works. It's full Linux. It's a Debian Linux derivation. I'm not sure which one. And it does support all the features on the Orange Pi you download it for. But you quickly find out there's some serious limitations, and it won't run most of the other Linux distro applications. Orange Pi does support a store, and there's quite a bit of stuff on it, but getting stuff to work can be an issue. The operating system that I use on the Orange Pis is Ubuntu. Whoever did that port did a great job. It supports all the features. I'm a Ubuntu fan from way back, so for what that's worth. Whoever did it did a great implementation. But when you go to the new Ubuntu store is called Snap Store. And when you go there and try to install one of the applications, about half of them will give you a message that it's not yet ported to this platform. So for what that's worth. They do have an Android distro on the website. And it was painful. That's all I can say. It's just, don't try it. It hurt. It's awful. I don't need to go into more. There are a couple of others. In contrast to the Raspberry Pi environment, I haven't found any third-party OS ports, where for the Raspberry Pi, there's dozens, and some of them are wonderful. They're about 3 generations back on Macintosh, but somebody has ported or rewritten the entire Mac OS environment to the point where it will run Mac OS applications from about 2 versions back on Macintosh operating system for the Raspberry Pi. If you like Mac and you want a cheap one, there you go. As I said, the hardware is cool from these guys. Here we go. This is the, I'm going to start these around, but I'll talk a little more detail about them. This is the Orange Pi 5B. It has onboard eMMC 128 gig on this one, which means it doesn't have an SD card slot, but you can immediately burn that SD card onto the onboard effective drive, and it makes a nice package. It has built-in Wi-Fi and Bluetooth with funny little antennas. And I'll talk a little bit more about the features, but this is, I like this, cool product. And next is the Beast. This thing, these are a little more expensive. I'll talk about that in a minute, actually. I get ahead of myself. What happens when you get old? You're never actually in step, you're always way behind or ahead of where you're trying to get to. This is the Orange Pi 5 Plus. It does not have built-in Wi-Fi and Bluetooth, but it has an M.2 connector on top you can plug an adapter into, and it works beautifully. It has 2 HDMIs out and a high-resolution HDMI in, which is cool if you can find software to take advantage of it. And it has both an onboard eMMC connector to put a embedded multimedia card. Remember all the acronyms. And also has a 4-lane PCIe connector on M.2 connector on the back. You put that has full NVMe support, so high-speed hard drive support basically built in. Hardware is a beast on this. Software, again, not so much. But Ubuntu, whoever did the Ubuntu port did a good job. I'm going to talk a little bit more about the features. There's some, if you look, sometime if you just want to see how much stuff Amazon has, just do a Raspberry Pi case search on Amazon. That's amazing. You do the same search for Orange Pi, there's 4 or 5. Which is okay. You can get them, any of the Chinese people that'll ship you stuff will ship you Orange Pis. But Amazon has them too, and their prices are very competitive for what it's worth. This is the Pi 5, pardon me, B, where the Raspberry Pi from 3 on is a quad-core architecture. The Orange Pi is a 8-core architecture, big little, all 64-bit, but 4 high-speed and 4 slower speed processors. So again, processing power is amazing. Has, I think, 3 camera inputs, built-in Wi-Fi and Bluetooth, and on the 5B, the eMMC is soldered into the board. You order it with that onboard hard drive effectively installed. And these on Amazon run around $147. So again, it's significantly, on the other hand, the Raspberry Pi 5 that I ordered, which was the company price, with 8 gig of RAM, was $85. So they've still got the 4 gig version at like 45 or 50 bucks, but they've had to start increasing their prices a little bit too. So these guys are not entirely out of the game. But even on the 5B here, the hardware is pretty impressive. And then the 5 Plus, again, that NVMe PCIe on the back with 4 lanes. I have checked the speed on it. It's phenomenal. It's everything you would expect from fully supported NVMe, which is cool. talked about the MMC, and again, you have to add that Wi-Fi or Bluetooth module onto it. I like it. I'm the you want to call it aesthetics, as a guy who's done some engineering and designed a number of circuit boards. This is a pretty circuit board. They did a nice job on it. It's cool. I like the vertical connections. It's got two 2 gigabit Ethernet connectors. It's cool, but the software, not so much. Anything else I ought to say about that? It does have a microphone on board, which is both of them do, which is kind of cool, but okay. It's like the Chinese radios we get now. Every damn one of them has a flashlight built in. That's cool. I like it, but it's a radio.
Did I use the flashlight?
I know. It's like the first time I got a phone where they turned the camera light into a flashlight. I thought, what the hell? And I use the damn thing all the time. So, what can you say?
I have spent hours looking for my iPhone using the flashlight.
And then you use the flashlight on the iPhone to look for your radio.
Good one, Jim.
Okay, that's any questions about the Raspberry Pis or Orange Pis or other? As I said, there are dozens of other single board computers. I didn't think I needed to do a review of all of them for you, but there's some cool ones out there. If you look at doing Googles of 10 bests is always
Like that flashlight.
yeah, you never, who's doing this and why is always the question asked. Yeah.
Just bringing this back to ham radio.
Yeah.
I think I've seen a Raspberry Pi solution, but that's the kind of interface, and then there's the that's controls your VCO.
Yeah.
And then there's some support.
Yep.
This application.
I have used. Well, talk. Oh, actually, that's since you brought that up. I don't know why I'm doing hardware development again. I was a marketing guy. I'm a physicist, but I found out I made more money doing marketing than I did doing engineering. So but I end up doing a fair bit of hardware design for some reason. I don't know. And I found this thing, which is really cool. You can mount a Raspberry Pi and an Arduino on it and have a breadboard there. And it's just kind of cute. And I think the blue thing was with the breadboard was like $15. So, and Amazon has learned to show me that kind of crap. And then I look at it and say, I don't need that thing. Yeah, $15.
I now.
How many have been there? Yeah, Okay. Radio stuff, finally. If you look for, again, okay, I lost track. Google search 10 top something or others. 10 best SBCs or something. You'll get the list, but there's a lot of neat stuff around. If you look for radio stuff, amateur radio stuff on the Pi, one of the first things you're going to run into is ham Pi. And I think there are, and this is, you can either download an image with all this stuff, and there's another page. I'm not going to read through these, by the way. I just wanted to impress you with how many there are. Having said that, there's something like 40 of these, and you can download them either as an image or you can download a script that will install all of them for you, which is, they did a good job. Of these 40 applications, maybe half of them are actually useful. They all work, but some of them you get into it, it's like, yeah, that's cute, but I don't care. But there are, the FL Digi works nicely. There's 3 or 4 or 5 different loggers built into this, which if anybody else went into the Nex products, these things, this looks like a notebook computer. It's not. It's a display and a keyboard and a trackpad and a great big damn battery where the computer would be. So for your Raspberry Pis, you can plug it into this with one cable, and you got battery and keyboard and touchpad and touch high resolution display, which is kind of cool. They're not cheap, but they're cool. There's some good GPS stuff. Chirp actually runs on it, and it's not necessarily the latest release of Chirp, but it works. The latest radios anyway, because I've got too many old ones to justify getting any new ones. So
There are SDRs, there's 4 SDRs.
yeah, and the SDR Angel is included in this, I think. I'll have to look. SDR Angel is cool because it's one of the few SDRs that fully supports transmit on SDRs that have that capability. In particular, what it supports is on the Lime SDR. And if any of you, the Lime group, their first product was a single receive, single transmit board. And the last one that I bought one of had 6 independent receivers and 4 independent transmitters at up to 100 milliwatts. And SDR Angel can control all of that, which is kind of cool. The Lime SDR was much more targeted at Bluetooth and LoRa and Wi-Fi development, so it goes up to those frequencies, than an amateur radio. But it works, I think it goes 10 kilohertz up to 4 gig. So I've used it as an SDR for amateur radio, and it's great. And again, it 100 milliwatts transmit, but we've got a transmit solution in a relatively low cost SDR now. I'm kind of stunned that SDR Play hasn't done that yet. I talked to them when I bought my first Play 5 years ago. I think so, because I did a presentation on Slow at the fire station, maybe longer than that. I actually talked to the guys at SDR Play, and they said, because I opened it up and looked at the PC board, and there were pads there for transmit stuff. Because it's really, if you got an SDR receiver, doing SDR transmit is actually really easy. And they, at that time, they told me they were planning on adding transmit capability. And I talked to them a little bit more and said, have you gotten into the regulatory issues yet? And they said, well, we're just starting to look at it. Okay, it's going to be a while. Because if you've ever looked at regulatory issues on RF transmitters, Dave, did you ever go up to the old RF site up on Briargate Hill with a product? At Hewlett-Packard. And at one time, Hewlett-Packard was the largest single private employer in Colorado Springs. And up on top of Briargate Hill, where the Czech company is now, the baseball field, that's a Hewlett-Packard Redwood building. They had 40 acres there, and they planned on building 13 of those buildings on that site in the early 80s. And then the instrument market fell apart, and the Japanese came in and ate our lunch, and then the Koreans came in and ate the Japanese lunch, and then the Chinese came in. And anyway, enough of that. But the point is, we had a full FCC RF test facility in the open field at that time, just north of the facility. And I spent days up there trying to get products to pass emissions. It's painful. Here's more stuff on the Ham Pie site. Caught a couple of neat clocks. They do have a product to do cat control for a lot of different radios. The control GUI is not real sophisticated. It's not like who's the software company? Used to be free. Anyway, it has a wonderful GUI, but it's like $150 now. So free one here. GS8 works good here. I've tried it. Anyway, if you want to, neat thing is you can get a whole bunch of crap to play around with on your Raspberry Pi to look at doing ham radio stuff with. And we agree that there's probably less than half of it that any given person's going to find useful. But that half is going to be different from person to person. Okay. Finally, why single board computers? I grew up in the Unix environment. I wrote, won't go into the story, but I wrote machine code for an IBM 360 170 to do fast Fourier analysis in the 70s. And it was machine code for an IBM 370 is the most arcane thing anybody could ever want to go into. But and that was not a Unix environment, but we're here. But the first Unix operating system was sort of written in the mid-60s, AT&T. And we're here at 2023, and all of the other operating systems have gone away. Unix won. Android is Unix. Mac OS has been built on a Unix kernel for 15 years now. Windows from NT on was built on a Unix kernel. How did the first operating system win? Because it's really good. That's the but like I said, I grew up in Unix, so I like Unix. I was privileged. How many people know about Silicon Graphics computers, SGIs? Okay, cool. I got to go to Silicon Graphics Advanced System Administrator training in Mountain View, California. The most amazing. I was sitting there in a class with 10 other people, and each of us had our own SGI Onyx with 2 reality engines. This is $1 million computer at the time. It was amazing. Anyway, I love Unix. And I now own 5 SGI computers. And of all the Unixes that's a terrifying thing in and of itself. It's like, how many oscilloscopes do I have? We won't go there. And why? But of all the Unixes I've played with, and I've played with a lot, SGI's Unix is my favorite. It's not real robust, but they put stuff in it that's just kind of weird and it's fun. Anyway, as opposed to notebook computer, I've got lots of Windows computers. I like Windows computers. All of my Windows computers dual boot Ubuntu and Windows, because that way when Windows goes bad, I can fix it. But none of them support GPIO. I don't have a bunch of little pins that I can stick stuff into and flip switches or measure voltages with, except when I hook up my HPIB to USB converter, and that's another thing I don't, anyway. But having that ability to control stuff is something these guys never had. And we used to do it with parallel ports, which is another weird thing. But that ability to control stuff in the outside world is a big part of what I like about computers. And you can do that with these single board computers. They're just much more flexible in many ways than a PC is. And the cost performance is, I mean, Windows computers have gotten cheap. This, the one I'm running on here is really nice Windows computer. It's a Ryzen 5, all the power I need. I do video editing on it. I think I got it for $500, but that's still, I'll talk a little bit about the Raspberry or Pi notebook things here. I think the most expensive one of those was about $200. So, and SBCs are very customizable. You can put neat cases on them, plug shit into them. It's fun. Finally, I'm not going to talk a lot about the difference, but every time I talk to people about this stuff, somebody says, well, why can't I get an Arduino for $10? It's because they're not a computer. They're a microcontroller. And there's no operating system, no user interface, no nothing. I use a lot of Arduinos. You can see my development board there. But generally, after I've breadboarded something, I immediately just order a chip or pull one out of the tube of them that I've got under the desk and build a board around it or do dead bug soldering to the pins. And because all that board really is to provide a USB power connection and programming environment for the chip. Okay, that's all I've got. Let me real quickly talk about these things just because I like them. Company called CrowPie started making accessories for Raspberry Pis. And there's actually one before this. It's a little suitcase thing that has a small display, but it has a bunch of, it was aimed at kids, but it has a whole bunch of the LEDs and little displays and joysticks and stuff you can learn programming with for kids. And the follow-on product to that was this guy. And it's got all those things built in to a notebook computer. This one doesn't have a battery, but it's got a really neat keyboard that holds in magnetically. And when you pull it out, this has got a Raspberry Pi 3 underneath it. And it's got all these things you can play with programming in it, which is kind of cool. I believe the follow-on to that was this, and this has a battery in it, and it's much more sort of professional oriented or hobbyist versus kids oriented. And it has a slide down keyboard, the Pi's in there, but it has a breadboard right in here next to the Pi. So you can, again, it runs on batteries. And there have been times when I've been out camping and pulled it out and just played with throwing a circuit together. And then finally, the current product, I think, is this guy. And it is a fully functional Raspberry Pi notebook computer. And it does bring out the GPIO interface, but just through a connector on the side that you can plug in a breadboard to and play with it. So if anybody wants to see those, they're just kind of neat toys. But I end up, and I write Python code on my Windows notebooks or boot them up in Ubuntu and do it there, but kind of nice to be able to do it on the architecture you're actually going to be running the stuff on. Okay, I think that's about all I've got to talk about, and we're about the right time. So anybody have any questions or?
Yeah, Chuck.
Yeah.
Some time ago, it was a couple years ago, I think, we had a Raspberry Pi presentation.
Yeah.
And I don't know whether it was with the software-defined radio to the SDRs or how he did it, but somebody had a vacation cabin.
Yeah.
And they used the Raspberry Pi through amateur radio
Yeah.
to control the burglar alarm and
Yep.
hot water heater, things like that. Do you recall how they did that or how they integrated that?
I remember the presentation. I don't remember exactly how he implemented it. I know how I'd do it. I'd use an RTL SDR, which I can pick. I've got a drawer full of them, but you can pick one up for $12 on Amazon. Works beautifully at on the 2 meter or the 70 centimeter band, and plug that into SDR Angel on a Raspberry Pi 3, and you've got a fully functional little radio with GPIO and everything else you could want. Great programming environment for what, $50?
And then you can use that software through the radio signal.
Yeah.
To
you would have to program that in the Pi, but yeah, you can absolutely leave the RTL SDR tuned to have it tune to a particular frequency, and just start. I use a frequency shift key digital communication with it. And yeah, it'd be easy enough to set it up to upload, download programs and control it and anything else.
Send DTMF
Yeah.
to it.
Yep. Yeah, that's right. I think, I don't remember who presented that, but they were using DTMF just,
think it's John Roach.
yeah.
Yeah, I think it might be John, yeah.
Yeah, he was just using dual tone multi-freak, so you could do it from the keyboard on your walkie-talkie.
Yeah.
Which is kind of cute.
And reliable.
Yeah.
Speaking of an SDR dongle, just a couple of weeks ago, I had a FlightAware feeder, ADSB feeder fail. That thing had been up in my attic for over 3 years. And I hadn't touched it.
Yeah.
And it was still feeding. And it wasn't the Raspberry Pi that failed, it was the SD card.
Yeah. Yeah. That's one reason I am really excited that Raspberry Pi is finally putting another interface on, because SD cards are questionable technology in my mind. That's not an adequate storage solution. Yeah.
Supply chain issues with the new Pis, the latest release.
The 5, I've read, yes, the operating system is not fully supporting like the PCIe interface yet. There are some issues with that. I do know one guy that has got a very high performance NVIDIA PCIe graphics card working through that connector. And he said the performance, he big card, he bolted the Pi 5 to the side of the card. But yeah, there are some issues with, and there will be.
Another ham radio application, the big dish down in Haswell, the DSES dish is actually being steered by Raspberry Pis today.
Really?
Yeah, that was rewritten just recently by some guys that I know. They're not hams, unfortunately, but no, that's how they're tracking the moon, is that the Raspberry Pis are driving the servos
Yeah.
that turn the dish.
It's
They're upgrading the encoders right now, and so there's a software change.
Yeah.
And I'm using a Raspberry Pi with Node-RED to do turning my antenna. So my ham4 rotor controller is talking to my Raspberry Pi that I wrote the code for steering it and displaying the pointing system.
Yeah, from what I've seen, the Node-RED and the LoRa support, programming support is, and Arduino for that matter, is significantly better on the Raspberry Pi environment than it is in Windows. And there's plenty of horsepower in the Pi to do that. So. Any other questions or comments? Yeah, I apologize for not having a Pi 5. That's the way it works. And if any of you have seen me present before, I generally, if I do presentations here, it's all radio stuff, and this wasn't that. But on the other hand, I guess I was the only one that stepped up to do a presentation this time. So this is what you get.
Thank you very much.
My pleasure.
Appreciate that.